So I have to do it again. Yeah, so good afternoon you all again. The main purpose of today's meeting is that how we do quantitative analysis of empirical data with comprehensive usage of SPSS tools. Okay, that's the main purpose. And if you go to Optima, and in the study material, there is a subfolder called spreadsheets. And in the spreadsheets, I can, as you can see, hopefully, that I have added two files today. One is SPSS raw data, which is in the Excel format. And there is also SPSS data, which is in the SPSS format. But I would advise you, actually my initial plan was that I will not play with Excel today at all. And I would straight away touch this file, but I would not do it. What I'm planning to do that, I would start with this first, how we move the file to SPSS workspace. Are you getting what I mean? So what I can do now, you can see here, I hope you can, let me see the spreadsheet. Yes, I'm sharing it with you. This is the data. Let's say if you do the quantitative research-based thesis, this is your spreadsheet. And let's say these are the variables. And what are the variables? The stock return, which you collect, the earnings per share of a company, the market value of the company, and we call it as, a layman would call market value, but you as a student of finance would call it market cap or market capitalization, which means what is the current value of the company now in the market. Operating profit, you know what is operating profit? The total revenue minus operating expenses is operating profit. The shareholders' equity, this is equal to total assets minus total liabilities. So whatever belongs to shareholder is called shareholders' equity. Debt liabilities, how much debt is there in the company, and what is the total assets? Total assets is called the book value of the market, of the company. Book value of the company. Do you know the difference between the book value and the market value? Total assets are representing the book value because this is the value in the books. But what is the value in the market? That keeps changing every second. Every second, the market value of the company is changing. The doesn't change for 3 months. That's when the new quarterly report is published. Every company, the listed company, they publish their quarterly report. So at least it stays stable for 3 months in the books. But the question is that, does life stop for 3 months? No, life goes on. And that is where we focus on the market value. So for example, this company, which is anonymous, the market value is something 203 million euros. The book value is 260. Does it make sense? So it means that in the market, the value of the company has gone down actually. I'm sorry I have to sit because otherwise I would look very funny in the video. so I can't stand, unfortunately. So it's like an imprisonment. All right. So what we do here, we move this data to SPSS workspace, and there is SPSS workspace. As you can see, this is a blank sheet in SPSS. So the formula is very simple. We never copy the text. We only copy the data. Okay, so if I select the data here, I have 151 observations. If you want to do some reasonable, good quantitative analysis, the number of observations should be, some people say 80, I would say anything more than 100 bring better quality of results. So here you can see that the number of observations which I have are about 150. So if I copy it and I move to the SPSS workspace, the first cell, the first row, first column, paste. and the data goes here. Can you see here? Let me see if it is getting shared. Yep, it is actually. Variable 1, 2, 3, 4, 5, 6, 7. We have 7 variables now. But they are anonymous, yeah? They are anonymous. Are they anonymous? Yeah. Whereas in the original spreadsheet, which we used, they have the name, right? They have the name. But in SPSS, they are anonymous. So first thing, I would suggest you that if you are in SPSS workspace, you can see here 2 bars. I don't know what you call them. One is called data view and the other is called variable view. Can you see at the bottom left hand, blue and yellow? Yeah. So the data view, and if you click variable view, it will show the qualities of the variable. As you can see here, variable 1, variable 2, variable 3, 4, 5, 6, 7. We have 7 variables. Is anybody left behind? Are you all getting? Yeah? Are you all fine? So you have variable 1, variable 2. So this is the data. But the question is that, well, you can do without naming them. There's no problem as long as you have got the codes in your somewhere in somewhere that who is variable 1, who is variable 2. As long as you know them, it's fine. But I think I would rather give them proper names. Then we proceed. Okay? As you can see, the first variable which I copied is called stock return. So I would go to SPSS again, go to the variable view and call it as stock return. I don't have to write full, and don't give space between the 2 letters, otherwise it will not catch. So I can call it stock return, yeah? Make sense? And then the data is numeric. I would suggest you always have 4 to 5 decimal places. In our original data, how many decimal places we have? Only 3, 1, 2 sometimes. I would say have at least 5 decimal places. You know why? Sometimes your findings are very small. Let's say your final answer is 0.003. And if you have only 2 decimal places, it will say 0.00000. And if all the cells are 0.00, you cannot operate any mathematical function on it. So have more decimal places. My rule of thumb, the way I do, even if the number is big or small, I don't care. I always take 5 decimal places straight away. Okay, so you can change. Like this is 2. If you see the drop down menu, you can make 3, 4, 5. 3, 4, 5. 3, 4, 5. Well, it can be 6, no problem. More is better to some extent. 3, 4, 5. 3, 4, 5. And then the first variable is stock return. Who's next? Second variable? Second variable is EPS. So EPS is straight away EPS, earnings per share. The third variable is market cap. You don't have to write full, so I can say market cap, but don't give space between the 2 letters. Operating profit. Operating profit. The fifth variable is shareholders equity. So share equity, okay. Sorry. The next variable is debt. Let's call it debt, just debt, that's it. And the last variable is assets. And now if you go to data view, you will see that they are no longer anonymous. Can you see them? Can you see their names now on top? So they have got the names. Okay. We all fine? Very good. Now, I have to move this bar somewhere so that it doesn't overlap with. Yeah. The most common function that we shall use in SPSS is called analysis. Is called analysis. You can see here there is file, edit, view, data, transform. I will use transform today, but the most common that we use is called analysis. Okay, can you see all? If you click analysis, you will see the descriptive statistics. Sorry, my throat is not well. It's called descriptive statistics, yeah? And then within descriptive, you can see descriptives. Are you all fine? Should I do again? Let's do again. So go to analysis, descriptive, and then the third level, descriptives again come here, yeah? Can you see 3 yellows? Analysis, descriptive statistics, and again, descriptives. Go to descriptives. And this is called, can you see here where the cursor is moving? Let me see if you are getting basically what I'm here. Yes, doing actually screen. I call it dugout. You know what is dugout? What is dugout? The dugout is the place where the players are sitting, but they have not played yet. And this is the play field, the empty one. So you as a team captain or a manager, you will choose who will be playing and or who will not be playing. Because I want to calculate descriptive statistics of each variable. So what I would do, I would select all of them by using control function or the select function, or control function rather. Wait a sec. This. I can send them one by one if you want, or I can send them together, no problem. I can choose all of them. No. Okay. And then look at the options. Then go to the options. It means that this is the activity area, right? This is dugout. This is called the playground, the activity area. Sometimes you don't choose all the variables for an operation. Sometimes you give some rest to some variables. Okay, don't choose them then. And here, and if you want me to send them back, for example, I don't want assets, I can send it back. And if I want to bring them in, yes, no problem. So you can fiddle between these two sides. Then comes the options. The options are, we have the mean, standard deviation, variance, minimum, maximum, range. I hope you know what is mean. What is mean? The average, well, we have different averages. Mean is one of the averages. Mean is the value, the middle value. The median is the middle position. And mode is the most common value in the data, the one who occurs most frequently. Are you with me? Mean is the central value. Median is the central position, location-wise. And mode is the value which has the most number of occurrences or the highest frequency or most commonly observed value. That is called mode. We have to try something else to get median and mode, but here we can get mean. Mean is most often used in the empirical research, okay? So if I have to, and then you can see the minimum value, the maximum value, the range. The range is the difference between the two, the max and the minimum value. The standard deviation is the variability. The standard deviation is the variability, how variable a data is. Have I ever discussed with you about standard deviation? Huh? In finance, we discussed about standard deviation, because in finance, the idea was that risk, the life is uncertain, isn't it? The financial world is very uncertain. Uncertainty brings us risk. The question is, how do we measure risk in quantitative research? And then the best measure was we use standard deviation as a measure of risk calculation. Standard deviation shows how your data is fluctuating. Can you relate fluctuation with risk and risk with uncertainty? Yeah? Can you? Yeah. So the standard deviation is a statistics which we measure. I can say, based on my experience, when I do my own research, or the students who do with me with big data, we use mean, median, standard deviation. We don't do both. We use either mean or median, not both. Maximum value, the minimum value, the difference is called range. All right. That's what I suggest students to do quite often. But I have a right to choose. So here you can see that I chose mean, standard deviation, minimum, maximum. Variance I will not choose because there is not much difference. Variance is just the square of standard deviation. Are you with me? So I would rather choose one. Why to choose second? And afterwards, I can make a selection. Why can't I move it? So yeah, that's it. And then I click OK. Then click OK. And you find some table called Descriptive Statistics. Do you all get it? Descriptive Statistics. And here you can see that the stock return is of 150 companies. The maximum is something 42. The minimum is very low, something 1.8. The earnings per share minimum, the maximum. And you can see here, this is the, didn't I choose the range? Range I should have chosen. Maybe I didn't. I can do it again, no problem. Where is the data? Analyze, descriptive, options, range. Yeah, that I should have chosen. Yeah, it will come again. Why is range not coming? Sorry, I'm just trying to. So you can see that we have the descriptive statistics, and the beauty of this table is that you can easily, you don't have, when you're writing your thesis, you don't have to type it again. If you click it, if you copy it and you take in spreadsheet, for example, so you can have those numbers back in Excel. Okay. So you don't have to type them again. But the question is that in thesis, I don't want to see your decimals to 5, 6 places, right? Does it make sense? So what we can do is, we can choose the data and then we do the formatting. Format cell to numbers. And here again, you can choose 2 places. So the numbers are reduced, basically. Does it make sense? Because in the thesis, you don't have to write decimals to 5, 6 places. Have you seen what I've done? Okay, I go back. Now here, so here you can see that this is the original output, which I copied from SPSS output, yeah? But you can see that, for example, mean of stock return is 11.774467. This is too big, too many decimal places. I chose multiple decimal places because that makes your analysis in SPSS really cool, believe me. But when we bring this output back to thesis in Word or in Excel, these 5, 6 places are annoying. They look clumsy, don't they? So what we do here, you can select the data and go to format cell, choose the numbers and have 2 decimal places, okay. And guess what? Now our data is looking better. We don't have so many decimal places. And that's the way you should write in the final thesis. Okay? Sounds good? Now, we go back to our spreadsheet, our SPSS spreadsheet. And once again, let me check if this is visible, because that's very important that sometimes I change the screen and it's not visible in recording. Now, the next thing I want to do you want to see how we find median or mode? Because remember, in this operation that we did, we could not find median. We couldn't. In that case, if you want to find median, go back to analysis, descriptive, but this time go to frequencies. Can you see here? Analysis, descriptive statistics. And once again, not this time this, but this time the first one, frequencies. Here, if you want, you can select all of them together in the one go. This is dugout. Take them to activity area, statistics. There is, look, you can get mean, median, and mode again. Yeah. Remember, we were missing median and mode. But if you go by frequencies, analysis, descriptive statistics, and then frequencies, then you can also find mean. As a matter of fact, you can find all these things again. You can find quartiles, you can find standard deviation, minimum, maximum, range. Why not? And continue, and okay. And there we are. This looks even better. I never tried this before. So you can see here the stock return, the mean value, the median, the mode, okay? The standard deviation, the maximum, the minimum, and the range, percentiles. You know percentiles? The first quarter of the data. We never do second quartile because second quartile means the middle. 2 quarters means half. Half means median. But we have third quarter, first quarter and third quarter. Okay? Are you okay with this? Right? Okay, good, good, good. Now we go back to the data, which is here. So you can see here, I have, or you also have, 2 sheets simultaneously. One is the data, and the second is the output. Okay? And at any point of time, if you click, for example, this big thing here, this yellow outline, if you can copy it, you can bring to your spreadsheet and just paste it, so that in thesis, when you want to bring the output from SPSS, to your Word or spreadsheet. You don't have to type it again. It comes automatically. And then you can change the number of decimal places you wish to. Usually, depending upon the situation, if the number is a normal number like 73 point, you don't have to write 73.37896. No, just 2 decimal places is fine. But if a number is 0.0034, in that case, we might go to 3 or 4 decimal places. Okay. Now we go to a very important tool called correlation. And we shall use Carl Pearson's coefficient of correlation. So what I'm going to do is, once again, we go to analysis. And here you see correlation. Can you see the correlation? Analysis, correlate, bivariate. Analysis, correlate, bivariate. Why bivariate? Because even though we have 6 or 7 variables in this case, but at a given time, we will only find correlation between the 2 variables. Make sense? So when you choose it, once again, you need to send data. You can select all and then make one push to the activity area, or you can choose one by one. It's up to you. And then comes the options. The option is, actually, we don't need any option. It's fine. All is good. Now here, I think I'll explain it when the output comes, and then click OK. Just OK. And there is correlation. This is correlation, yeah. The correlation coefficient between 2 variables show the degree and direction of their association. For example, here in the earnings per share and stock return, their correlation is approximately 0.42, which means that if there's a 1% change in one of them, there is 0.42% change in the other. Do you get my point? Okay. Correlation, the minimum is -1, the maximum is +1. It can be 0 as well. 0 means no correlation. Does it make sense? And why I call it degree and direction, because here the degree is 0.42. Let's count it 0.42, yeah? Which means 42%. Direction is it positive or negative? It's positive. Can you find negative correlation somewhere here? There is one here actually. Assets and stock return. Assets and stock return. Can you see here? 0.773. It means what? It's a very big statement. Very interesting result. The assets and stock return, which means that the companies which have more assets have lower return. So if your assets go up, the company's stock return goes down. So basically, we are making a conclusion that small companies, small-sized companies, perform better in the stock market. And the big-sized companies having big assets perform bad in the stock market. What is bad performance? When your stock return is low or even worse, negative. So in this case, you can see that if the company's assets grow by 1%, the stock return will go down by, let's say, 0.7%. Okay, so this is a negative correlation. So mark my word, correlation shows the association between 2 or more variables. Here I'm studying 2 variables at a time. 2 variables in this case, and what we study, their degree and direction. Direction could be plus minus, degree could be the size. The thing which you want to focus, can you see here the stars? 1, 2, 3, somewhere. Can you see some stars here? This is called how significant the relationship is. Sorry, my voice is very hoarse today, unfortunately. Okay. The significance level is very important. The significance means that is it even relevant? When you ask this question, okay, this is a relationship, but is it even relevant? Or is it just because of some random movement? I can assure you, I can bring a variable called the amount of marbles sold in Finland, the amount of rainfall in a year, and number of petty crimes in Helsinki. 3 variables. Do you think that the 3 variables seem to be logically connected? But if I find some correlation between these 3, there would be still some value somewhere. Question is this value relevant? Or is it just some random thoughts, fantasy? It means that there is a value, but it is not significant. Significant means how important it is. Now here, you can see here, correlation is significant at 1% level of significance, two-tailed. Now this is something which I need to discuss with you. I better stand. I'm tired of sitting now. I think I can't get my voice if I'm sitting. Significance is very important. I try to bring this, show it. I don't know how much I can show it, but I try. There is a concept called level of significance. And here, the second one is called level of confidence. If I use 10% level of significance, I'll come to it. When I say 10% level of significance, it means that I'm prepared that my results can be deviating from the true results 10%. And if I use two-tailed test, two-tailed is like this, one-tailed. Have you seen this curve before? Like bell-shaped normal distribution curve. So some rising, some falling. So 5% on this side, 5% on this side. It means that this is the amount of error I'm prepared to accept. Sorry. Imagine. Okay, I'll come to this situation later on. So this is 10%. It means that we can give a leeway of error of 10%. It means that we expect that our results will be true to 90%. And if we use 5% level of significance, then 100 minus 5 is 95. You expect your results to be true 95%. And if you take 1% level of significance, then you expect your results to be true by 99%. Make sense? Okay. So lesser is the level of significance. More confidently, you can say that your results are true. We never take more than 10%. because more than 10% means your results will be true by less than 90%, which is unacceptable in empirical research. Okay? For example, if there's an investigation or some crime investigation, and you are the inspector, and you make a report to and your senior is your thesis supervisor, and you are the researcher, like inspector, you make some investigation, your teacher, your supervisor will ask you, have you solved the murder mystery? Yes, the murder mystery is solved. This is the character, this is what happened, and this fellow is the prime suspect. Your boss will ask you how much confident you are. And you say that I'm 90% confident. So there's still 10% chance that he may not be. And your boss will say that I cannot put somebody behind the bars when you are 10% unsure. You get my point? So then you do further investigation, 5%, till you come at 1%. Your report will be not so accepted. But in the empirical research, we can accept up to 10%. It depends upon researchers. I think some people put a bar at 5%, but I do accept 10%. It's fine. Now here, for example, if you look at this result, this one, what is here? 0. And when you have the 0% level of significance, what is your level of confidence? 100%. So you can say with 100% confidence that the correlation between earnings per share and stock return is 0.42. But for example, here, let's say this one, the correlation between debt and the earnings per share. Sorry, debt and the earnings per share. First of all, the coefficient is, the correlation coefficient is positive 0.14, which means that the companies which have more debt have the higher earnings per share. Does it make sense? So the more levered companies have better earnings per share. But the question is that how confident you are. See, the one is that you make a claim, and the second is how confident you are. And this makes difference between statistics and econometrics. If this course name was statistics, I think I will not care too much about the level of significance. But in econometrics, we are comparing some real phenomena. In stats, we shall use them X, Y, something, A, B, C, but here there are real variables. Look, I have 150 companies from Finland. Real data, everything's real. And two very important variables. One is earnings per share. How much the companies give, how much is the net profit divided by the shares? How much money belongs to each shareholder, each share? And then the amount of debt which companies borrow. Both are very strategic variables. So I have to see not only their numeric number of the result, but also if the relationship is significant or not. And if you see here, it comes to be 0.8, yeah? 0.08, I guess. So can I say it 8% or 9%? Isn't? Do you know which cell I'm talking about? This cell. How much is this? 0.8. 0.08 or something? Is it? So I can call it 9%. So it means that I can say with 91% confidence that there is a positive association between the debt and the earnings per share. And what is my interpretation, how I will write it? Based on the empirical findings, we can say that companies who borrow more have better profitability. So the company which borrow more have better profitability. The profitability improves. That's why their earnings per share is more. Are you with me? Earnings per share is calculated after all the expenses, your net profit. The last value in the income statement is called net profit. Net profit divided by how many shares we have. That is called earnings per share. So the companies which borrow more are able to perform better. They are more profitable. Remember the management accounting course, you did profitability ratios also. And one of them was earnings per share. So now here, for example, where are we? Look at this one. The stock return and operating profit. If it was a statistics course, you will say the correlation between operating profit and stock return is minus. But look at the level of significance. It's 0.635. 0.635 means 63.5%. 63.5%. You are telling your boss that you did some research, but there is a possibility 63.5% which you're not sure about. Is it acceptable? No way. Absolutely no. So you can say that the correlation or the relationship between the market stock return and the operating profit is insignificant. The coefficient is there, the correlation is there, but it is insignificant. This is inconclusive. We are not in a position to make any conclusion about this relationship because, as I said, we never take this level of significance more than 10. It's like a limit. Okay. If I transform this example to the medical examination, the results are true. When you go for some blood test or something, there's always a range, the lower side and the upper side. Okay? And the test is considered to be more rigorous if the range is small, if the variation is small on both sides. So it's like that. If a doctor is giving you some kind of diagnostic, and doctor says that this is your test result, health check, but there is a 33% possibility that the results could be either side. No, that is not a good examination. You have to be very accurate. Of course, you cannot be accurate 100% confident. Well, in this case, we have seen that there is one case, or rather many cases, when the level of significance is 0. It means you can say with 100% confidence that there is some correlation between the two variables. But I would say that as long as your level of significance is 10 or below 10, it's perfectly fine. But I would strongly discourage you to go beyond 10%, because if this is more, then your level of confidence is shrinking. Okay, we want to have it as much more and more possible, and that's only possible if this is smaller and smaller. Look, 10%, 90, 5% more confidence, 1% almost 99%. In this case, we have seen there are some 0%, almost 100% confidence. Isn't good? But anything, so never take your level of significance more than 10. That's the lesson. Any question? And the next thing, I will discuss with you is regression. Are you all okay? You fine? Yeah. So once again, for regression, we go to analyze, regression, linear regression. So you can see, I make a pause here. Analyze, regression, linear regression. Okay. So we click this. Now here you can see that we have a dependent variable. Dependent variable, let's say our model says that stock return is a dependent variable, so I take it here. I can only pick one dependent at a time, but I can pick the others as independent variables, no problem. So let's assume that they all are independent variables. It's like saying that if I can say that y is a function of x1, x2, x3, how many variables are here? We have 1, 2, I think we have how many? 1, 6, yeah? So we have x1, x2, x3, x4, x5, x6. But the dependent variable can be only one at a time. But you can have, and this is called multivariate. Why we call it multivariate? Because there are multiple variables. If it is only one variable here, one dependent, one independent, it's called bivariate. Bi means two. Because we have many, so we call it multivariate. It's called multivariate ordinary least square regression. Or we call it OLS. So this is the whole analysis. Multivariate, ordinary. Why multivariate? Because there are more variables. And this is the ordinary least square regression analysis. Why this is called linear least square? Because the relationship between the variable is assumed to be linear, like on a straight line. So we choose them. But here again, we can pick up, can you see here there is statistics, yeah? Click statistics. We have, look at here, confidence interval. Do you know what is confidence? You know what is confidence? What is confidence? To be sure. To be sure. To what level? To what level you want to be sure? Minimum. 90%. So what you do here, you can choose it to 90 by yourself. By default, it's 95. 95 means there is a 5% level of significance. You remember this sheet? When it's 95, the level of significance is 5%. It means you are prepared mentally to give a leeway of 5%, this or that. So you're like a doctor, you can say that, well, I have done some blood test, but I'm 5% uncertain. I've done another test, but I'm 10% uncertain. But then, so this number should go down. But as I said, in the empirical business research, we are fine with 10%, but this should not be more than 10%. Because if this is more than 10, this should be less than 90, unacceptable. But by default, it comes to be 95, so change it to 90, yeah? Then I'll explain their meaning, but I would say that must choose, you can again choose descriptives again if you want. They can come again. They're harmless. Collinear diagnostic and Durbin Watson. I'll come to them, but just remember, when the output comes, I'll show you what it means, basically. Estimates will come automatically. You can't change them. Confidence interval should be 90. By default, it's 95. Make it 90. Model fit is good. Descriptive, you may choose again. Well, you may like them. Collinearity diagnostic is good. And Durbin Watson is something which you should choose. And after you have it, click OK. And then finally OK. And there we go. We get the results again. Do you get them? When you all get them, let me know. Yeah. How about you girls? Did you get? Okay. And everybody? So the first thing is R square. What is R square? What is the value? Somebody shout out. What is R square here? Vera, how much is this? R square is 335. Yeah. If I write it in percentage, it will be 33.5%. Basically, it means that your y is equal to function x1, x2, x3, x4, x5, x6. 6 independent variables are impacting one dependent variable. And the combined effect of all 6 variables is showing 33.5% changes in y variable. So you selected 6 variables, right? The change in y, the dependent variable, which is stock return in this case, 33.5% change is explained by all these variables together. Does it make sense? Remember, these variables are not the only variables in the world. Remember, I'm ignoring many things. For example, I'm not considering research and development. Am I? I'm not. What is the share of intangible assets? Am I considering? No. Am I considering the characteristics of CEO? No. Am I considering if the companies are exporting or not? How global they are? No. Am I writing that how many products they have innovated last year? No. There are many variables which I have not studied. So therefore, it's very much reasonable to expect that these variables which I did cherry picking. And how do I choose these variables, by the way? I must have justified them in my literature review chapter. That is why the literature review is Literature review is like a link man in the football match. He has to run backward to help his defenders and also forwards to help the strikers. So both ways. So that is why literature review is very strong element of your thesis. Okay, so these all variables combined are explaining 33.5% change in your dependent variable. It means 66.5% change is somewhere else, which this model is unable to explain. The question is that how much this is acceptable. There's no limit. As long as the variables are significant, it's fine. There's no limit. Nothing it says. I mean, if this goes to 93, or if this goes to 13, that will not question the validity of your results. Your results are still valid. So there's no magic figure. How high is too high or how low is too low. Nothing like that. Okay, because it's very much assumed that you are not able to shortlist all the variables in the world. There's so many variables, okay, which you can foresee, but there is a life beyond those variables also, which is beyond your perceptions. Here, the Durbin Watson test is 1.975, yeah? Durbin Watson test shows that how consistent, what is the gap between the actual value and the estimated value. You know, in the regression, we estimate. And if there is the gap between the actual and the estimated value remains very stable, consistent, the Durbin Watson should be around 2. Okay, if it is too much positive, it's 2.5. If it's too much negative, it's 1.5. So Durbin Watson, if you get between 1.5 to 2.5, it's not a big problem. I would say Durbin Watson should be between 1.75 and 2.25, 25% each side. But here, your Durbin Watson is great. It's 1.978 something. So it's close to 2. 2 is a very nice figure, magic figure. It means that the gap between the real value and the estimated value is not so haphazard, very consistent. And that's what we look for. Yeah. If this model, if Durbin Watson is too high or too low, it means that maybe the model you have chosen, this model is faulty. Either you have some unnecessary variables here, or you have some important variables forgotten, or your variable, your model form of the model should be non-linear, it's linear, or it could be possible that your data is very less. There can be many problems with it. Or you measured the variable wrongly. You measured the variable wrongly. How? Let's say your variable could be, I'm giving you non-finance example. The variable could be peace. How do you measure peace? Peace in the city. Crime rate, lower the crime rate, more is the peace. I'm not talking about the mental peace, I'm talking about the civic peace. What else could be the measure of peace in Uvascula? If I give a statement, Uvascula is a peaceful city, how would you measure, how would you quantify this phenomena called peaceful? So it means that if the crime rate is less, we can say that city is peaceful. What else could be a measure of peacefulness? The number of parks in the city? Some maybe kind of... Huh?
Maybe, but you cannot say it has a direct relation.
No, nothing is direct. I'm intentionally giving you different ways of calling peacefulness. Do you get my point? So I'm trying to give you different ideas of peacefulness. Now, as a researcher, you may choose one or two. But the question is that they may be irrelevant. Like, for example, you said that when I said that number of parks where you can go and have some peace, you said that it's not directly concerned. It means that I might have chosen a wrong measure. So you are criticizing me. That's what I want. So maybe I chose number of gardens or number of public parks as a measure of peacefulness. And you as a critic are saying that, hey, I took a wrong variable. I should have measured peacefulness in a different way. All right. If I say that the city's social amenities are very good, Uvascula provides very good social facilities. Now, I can measure how many primary schools we have in the city. So the primary schools, the number of children divided by the primary schools. So how many kids in one school? You can say, no. We should go beyond primary school and take high school also. And somebody said, no, 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 we go beyond and include these Gradia and the other places. And then say, why are you only measuring the education from students' point of view? How many new teachers have been recruited last 3 years? How many new buildings? How many more labs have come? The same thing we can define from different ways. And then you say, hey, why your discussion is only about education? What about health? What about Kesu Sarala? And then somebody says, okay, education, health. What about transportation? Public transportation is getting worse and worse. And then somebody says, what about the streets? So you can define this word welfare from different point of view. So maybe one of my variable is welfare, and I defined it wrongly. Okay, so there could be many reasons why your model can be faulty. Okay, and it's not a crime to have a faulty model. We are only researchers. We are not fortune tellers. We try, we fail, we again try. Okay, that's what the process is.
How much is this?
33.5% changes in our Y variable are explained by these 6 variables, and our result so far is really cool. 1.978 Durbin Watson is very good, very good. It shows that our model, which we formed, is good enough. We haven't made a bad choice. So it means that our theorization process has been very good. And then comes the ANOVA, analysis of variance. ANOVA means analysis of variance. Look, there are so many numbers here, but we are, like when we go for some blood test, yeah, and the doctor print out the report can be 5-6 page long sometimes, but only 2 or 3 things are important to tell you, yeah? So like here, there are so many calculations, but we only require the one which we needed. And here in this table, I will only see this and this. Only this and this, F and SIG. F test is very important. F statistics tells you, is your model's explanatory power good? Is your model explaining the phenomena? Are these 6 variables together are explaining the change in Y in a nice way, you know? Are they good enough to explain? Are these 6 variables good enough to explain changes in Y? Okay, and how do you know it? You look at SIG. What is SIG here? What is SIG here? SIG means significance. Vera, how much is this? 0. So it's almost 100% confidence. Remember, significance and confidence are opposite. When it's a 0% significance, go back to this sheet. When it's 0% significance, there is 100% confidence. Yeah. So you can say with approximately 100% confidence again that these 6 variables together are very good to explain changes in your dependent variable, which is stock return. Okay. Sound sense? Yeah. And then comes the regression output. Here we see only your estimates. B are your estimates. Can you see here B? Unstandardized beta. Actually, it's called beta. Unstandardized beta. Then we say T value and SIG value. Nothing else, nothing more. We only see this variable, T significant. So these are the cause variables, and stock return is the effect variable. The earnings per share. And one more very vital thing I want to share with you, that I don't pay much attention to the size of these numbers at all. For me, the most important things are 2. Number one, are they positive or negative? Number two, are they significant or not? Now, for example, earnings per share, it's positive, yeah? Look at the cursor here. It's positive, yeah? Significance, how much is this? 0. I can say with almost 100% confidence that earnings per share cause the impact on stock return. The question is positive or negative? The answer here is positive. The companies who gives more earnings per share to the shareholders, they experience very good performance in the stock market. The companies with more profits, they have better stock market performance. Market cap, positive, and significance. Once again, you can say with 100% confidence that those companies whose market value is getting bigger, well, I think this reason is very self-evident. The company who grow big in size in the market definitely are the one whose stock price is doing well. Okay? The question is that which of them is not so important? Actually, all of them are significant. So all these variables are, but you can see here that the debt and the shareholders' equity are having a negative relationship. So it means that companies which have more debt, or the companies where the the shareholders' equity is more, so they are having a negative relationship between the company's stock return, which is a little bit strange, because I would assume that either debt or equity would have the negative relationship with the stock, but here both are having a negative relationship. Okay, so all the variables are significant, basically. The point I'm trying to make is that when you look at the regression output like this, coefficients, only focus on 3 things. Beta, unstandardized. Don't look at the value. It doesn't matter, honestly. Just see the sign. And secondly, if the significance is, if it is significant or not. Once again, the rule is that highest level of significance is 10%. It means that significance level should be 0.10, not more than that. Okay? Yes?
Why don't we consider the actual value?
Sorry? The next time when we meet, we shall do non-linear regression, because life is not linear all the time. Life can be cyclical. Non-linear regression, we will be using a technique called logit and probit. If your dependent variable is a qualitative variable, yes, no type, then this technique fails, what I did. So I'll explain it to you. But one thing before you go, I want to, Bilal mentioned a very important word, even though he didn't mean it. In this data set, who is your dependent variable? In this data set, who was your dependent variable? Huh? Stock return. Are these actual values of stock return? Are these actual values of stock return? Obviously, yes, because that's what I took from Excel. Remember, I copied and pasted from a spreadsheet to SPSS. But are you interested to know, hey, what could be the estimated value of Y, the stock return? Look, we use Y, data, X1, X2, 150 observations, and then we estimate Y, yeah? So it means that the data which exists in spreadsheet is the real data, right? What about the estimated data? Estimate. What is the estimate? In this case, what we do here, go to analyze. Once again, go to regression, linear regression, yeah. Same thing, analyze, regression. Am I recording it? Yeah. Analyze, regression, and linear regression. And here is a function called plots. Plot. Click this. Not plot, maybe save. Oh yes, save. Go to save. And look at the title here, predicted values. Predicted values, it means what you estimate. And unstandardized. Unstandardized means the numbers, not the ratios. Because when I say word standardized, it means the ratio. Use the word unstandardized. Predicted value unstandardized. And then guess what happens? If I click OK, continue, and OK, guess what I get in the data? Look, there is a variable called pre1. It shows in your data. It comes back to data set. Does it come? It means that a company, let's say Nokia, whose actual stock return is 77%, the estimated stock return was around something 800% or something. So this is the difference. Actual stock return, estimated stock return. Some sense? So you could find the difference between the two. So one is the actual dependent. This is your dependent variable, okay? That's very important. I'm not talking about independent variables. I'm talking about the dependent variables, stock return. Actual values, estimated values, okay? And then can I call that the difference between the actual and estimated value is called an error? Can I call it error? Right? So what I do here, go to transform, compute a variable, and let's call it error, E-R-R-O-R. And the way I would calculate is, it will be equal to the stock return, look, stock return minus sign, where is minus sign? Unstandardized value. So I calculate one more variable. I can make a new variable called error. Not terror, but error. And this is equal to the stock return actual one minus, so I do it again actually. Sorry. So the error term, let's say the difference between the actual stock return minus the estimated stock return. And then I click OK. Where is OK? Huh? Yeah. Oh yes, there is, the first one is okay. So even though what is the problem with this? This was.